And we're started. Okay, so chapter 6 is all about how to make accurate samples or surveys. That's kind of the general idea about it. So if, let's say we wanted to survey the school about something, everybody in the school. Let's say Miss Dow needed to have some information for next year when she's coming in as the new head of school. And she wanted to get an idea of what the school thought about it. So one option would be is that she could go to every single class and ask every single person, right? Okay, that would be an accurate survey because you get everybody's opinion in on it. However, what's wrong with that kind of a survey? It takes too long, okay? It's very tedious and time consuming, especially if you were thinking you wanted to survey like the city of Richmond. You couldn't go to everyone's home. They're not going to be home. People are going to be on the, you know what I mean? Like you couldn't do that then. At a school, perhaps you could, especially a school our size, but not a school that's got 1,500 people in it, right? That wouldn't be accurate sampling. So what could you do instead of asking everyone? This unit is very much more on written answers or spoken answers, less on math. It's a lot about vocabulary. Landon, do you have an idea? But you don't have any data though. So we're talking about how to get the data. Like, how could I get an idea of what people thought if I didn't want to go to every single class and ask every single person? Eliana?
You could like post out like a survey card or something, and they.
Okay. You could send like through email a survey.
Yeah, or you could put up something and then have a box or anything. Oh.
Okay.
Just like what the high school students did for the music at lunch sometimes. They send out that. Oh yeah.
Okay. Sure. Would it be okay if I went to the middle school lunch and asked, let's say, 10 people at the middle school lunch?
No.
Would that be an accurate sampling?
No.
What's wrong with it?
It's not the entire thing.
Not everybody has the same opinion, but what group are you missing? We're missing everybody in elementary then. If you only ask people that are in the lunchroom during middle school time, you're missing half of the school.
And high school.
And high school, because high school is sitting there. Let's say I have a question about sports, and I go and ask everyone in the art room, whoever's taking art, and I ask them their opinion. What's wrong with that?
There are not sports.
Well, okay, you can be art and sports, but isn't that pretty limited because you're only asking the group of people that are in art?
That could be one grade.
It could be one grade level. It could be one interest. Depends. What if I was going to HEB and I had a question about the natural food options, and I ask everyone in the pizza aisle?
Good luck.
What if I ask everyone in the pizza aisle that I see? They might not even have any opinion about the natural food section. I mean, they may or may not, but that's probably not the best place to ask, right?
Yeah.
Or if I want to know if people want to continue in a natural food section, but I ask everyone in the natural food section, that would be called biased, right? Jude, can you put your backpack on the floor, please?
Yes.
Yeah.
So then we could do various answers.
Yeah. So what we're learning in this one is how to create an accurate sample to see whether the data is representative or not. That's kind of our main goal. All right? You're with me? Yes?
Sure.
Okay. Example 1. We have a video, so no notes on this first part. Yeah. I was prepared today. Might be too loud.
How can you use a sample to gather data about a large population? Think about this question during the lesson. The 2,468 registered voters in Morgan's town are voting on whether to build a new stadium. Morgan and her friends want the town to vote in favor of the stadium. How can they determine how the voters will vote before the day of the vote? How can you represent this problem situation using math?
Okay, so first of all, why might they want to know how the voters will vote before the day of the vote? Why would they want to know that? Mateo?
So they can get ready, I guess.
Yeah, because what did they want?
Yes.
They wanted people to vote yes. They want a new stadium. So if the general opinion is that people are going to vote no, there are things they could do then, right? Beforehand, they could try to sway the people's vote and convince them to vote yes. Or if the general opinion is that everybody's going to vote yes, then that's good, right? Then they can maybe relax a little bit more and assume the answer is going to be a yes, or hope the answer is going to be a yes.
Morgan and her friends could ask every registered voter, or the entire population of voters in town, how they plan to vote. Is it reasonable for Morgan and her friends to survey every voter?
Okay, we already talked about this. I think they said there was like 2,648
Yeah.
people. They're not gonna ask all of them. So no, that is completely unreasonable. So no, not reasonable.
Surveying thousands of people would take a very long time. Morgan and her friends would not be able to survey the entire population of voters. Morgan and her friends could ask a subset or a sample of the registered voters how they plan to vote.
Actually, we gotta take a couple of notes here. There was 2 vocabulary terms already. Did you catch what they were?
Subset. Yeah.
Actually, the vocabulary was sample. But before that. Okay? First word, oh wait, what are we on? 6-1, population. Okay, so number 1, vocabulary term population. Okay, population, what's population? You give me a definition of that, Nathan?
Like the total group of people?
Okay, it's
Like
all the
not-
people.
Yeah. all.
Yeah, it's not necessarily the population of a town, but if you're looking at your school, the population is all the people in your school. So I'm just gonna say all the people.
Or thing. It's like
No, when you do
animals.
surveying, it's always with people. Otherwise, you can't ask them a question.
Yeah.
Yeah, okay, so it's all the people in your city, all the people in your state, all the people in your school, all the people at your work. It's all the people of whatever you're looking at. Then we looked at, the next thing they gave was sample. They said that they could ask a sample of people. What does that mean? Yeah, like some of the people. Right?
If you saw them walking, you know, you'd be like, hey.
Right. So a sample is some of the people. And you can have a good sample or a bad sample. We were kind of talking about that. But a sample is where you just ask some of the people of the population. William?
So it,
Never mind. Okay. Okay, so population is the whole group. A sample is a part of the group. They also call it a subset, which is another math word, but you should be familiar with it. So a sample is also known as a subset. You know what the prefix sub means? Under. So it's like a population, but it's a group within that or under that. All right, back to this.
Surveying a sample of voters doesn't take as long and is more reasonable to do. Morgan and her friends would be able to ask 100 or 200 people. When you're choosing a sample, Why is it important for you to define the population as clearly as possible?
Why is it important to know what your total population is? Or to define your population? Donnie?
So your conclusion is accurate.
So your conclusion is accurate. That's really what it is. You need to know what group you're wanting to get information from so you know what kind of sample to look at.
It is not usually possible to study every member of a population. But if you know information about the members of the population, you can define and generate a representative sample. Now you know how a sample can represent an entire population.
What did they do?
It was a slider thing so you can see them.
So this is a way that you could choose samples, like who to ask questions to. One way is you could ask every voter that has a college degree. I'm not saying these are good samples, but I'm saying these are ways that you could group people. So you could ask everybody that has a college degree. You could ask every person that's over 30 years old. You could ask every female in the population. You could ask every male in the population. You could choose them however you want to. Yeah.
So just a question. If you are like, let's say I'm doing this, but I want to do 100 people, just as a sample, would it be wise to do like, try to do 50 males and 50 females?
Probably.
Would it be wise?
Probably. Your sample depends on the situation. For this one, I would say asking males and females would be good because they're both going to care about getting a new stadium. So like only asking females is probably not a good idea because then the males don't have a say and they're both going to want a say in something like that. Mateo? Yes. Okay, what about, so here's our situation. Look up at the board, I'll read it. Miguel thinks the science teachers in his school give more homework than the math teachers. Probably not true here, but go with it, okay? He is researching the number of hours middle school students in his school spend doing math and science homework each night. Okay, so he's trying to verify something that he thinks. So he wants to sample all the he wants to get information from all the middle schoolers about how much math homework and how much science homework they have. In that situation, the blank includes all the students in his middle school. What is the vocabulary term for that? If he's looking for all the people in his middle school, what would that be called? Nathan?
Population.
That would be called the population, because it's all the people in his middle school. A possible blank is some of the students from each of the grades in middle school. What would that be called? Yeah, that would be called a sample. A sample would be asking a couple of kids from each of the grades. Okay,
Make sure you make
we've already, what?
for that you have to make sure like you ask some of the smart people and other
Different kinds of classes and whatnot, yes. Yes. You wouldn't want to ask one 6th grader and one 7th grader and one 8th grader either, right? That wouldn't be a good sample. You'd want more than that. Okay? Why is it more efficient to study a sample rather than the entire population? We've already answered this, but let's say it one more time. Why is it more efficient? Jude?
One, it's easier and like you'll have like an idea.
Yes.
Like you know, I don't think you necessarily need to know exactly what
Correct.
everybody's doing at the same time.
Correct. Looking at a sample is just to give you an idea. If you actually take a vote with everybody, then you have an exact answer, but that's not usually what people are looking for. They're just looking for an idea of what's going to happen. Can your sample be too small? Can you ask too few of people?
Yeah.
Yes. Could you ask too many people?
I don't believe.
If you're looking for easy, you can ask too many people then, right? If you try to ask too many people, you might as well ask the entire population. I mean, if that's what you're doing. But you can have a sample that's too small. If it's too small, you're not going to be accurate. Okay, let's do these vocabulary terms first before doing the situation. So I want you to write down vocabulary phrase representative sample. Representative sample. It's a specific kind of sample. It is a sample that accurately reflects the characteristics of the entire population. Accurately reflects the characteristics of the population. What does accurately reflects mean? Accurately reflects. William?
It means that it's a pretty, it's a sample, this is probably what the most likely outcome would be.
Yes. Okay, so Jude earlier told us that asking a sample will give us a general idea. What a representative sample is it gonna give us a good idea? Like, that's what that means.
Like a very accurate.
Yes, yep. So we gotta go to the other example yet, or the other vocabulary too, but I gotta write something on here. So a representative. This is how my definition is gonna be. I want you to add it behind yours in parentheses. The way I think of a representative sample is it's just a good sample. It gives you a good idea of what's going on. You have asked an appropriate amount of people. You have asked an appropriate amount of varied people. It's a good sample. Like, you can trust the idea of it. Okay, then we have, the one on the bottom. Can you see that one? I can't scroll up anymore because it's at the bottom. But next thing you do, write down a random sample. In a random sample, each member of the population has an equal chance of being included.
So we wrote down.
Yeah, write down that definition. Everyone could be included. We'll have a lot more vocabulary this unit than normal. More vocabulary and less numbers.
Is the whole lesson just gonna be like, how is it gonna look like on the homework?
It's gonna ask you questions like, is this a good sample?
Oh.
Or it'll be vocabulary based questions. Okay, so random sample. Do we need a little more time to write? Yeah, wait a little bit longer. Somebody give me in your own words, what's a random sample mean? In your own words. Claire?
Ask you that.
Sure. We haven't done that lately.
Each member of the population will have like an equal chance to like be included throughout the survey.
Okay. So that means males and females have equal chance.
I really just want to say that.
I don't know what the sample is, but athletes and non-athletes have a chance. College grads and non-college grads have an equal chance. Like, everybody's got an equal chance. Ivan, do you have something to add to it?
Yeah.
What?
So Claire just copied it, so I'll just say everyone has equal chance.
Everybody has an equal chance. Okay, good. Evelyn?
Everybody might be able to be included into the vote or process. that's
Yes,
going on.
yes. So everybody's could be included in the random sample. Go ahead and have a seat. So I'm gonna add a couple things to your definition. So random sample. You have your mathy definition, but I'm gonna add to that just the fact that everyone has a chance of being asked. Nobody is automatically not going to be asked based on some kind of factor. And the other thing that was a part of that definition, I don't know if you wrote it down or not. Typically is a representative sample. What does that mean when I say that? That it's typically a representative sample.
Accurate.
Means it's accurate. Usually this is a good kind of sample method. How could if our population was our whole school, how could I do a random sample? We'll look at some examples yet today, but I want to see what you can come up with. How could I get a random sample from everyone at the school? So I couldn't just go into a 6th grade class, because then not everybody's got a chance to answer the question, because only the 6th graders are going to answer. So how could I make it so that everybody has a chance of being asked? Evelyn?
You can have more than 5 people to ask everybody in the whole school instead of just 2.
But that's not a sample, though. We still want it to be a sample, so I don't want to ask everyone in the school. I could, but I want it to be a sample. Jude?
You could go to a pep rally where everybody's there.
Okay, and how could you choose who to ask?
You go up where Coach says has a microphone and ask them. And
That's asking the whole school, though.
raise your hand or something.
That's asking the whole school. How could I pick people to ask questions, but make it random? I like the idea where everybody was together, though. That's a good idea. It's just how then do we ask them? Jace?
You could ask during a middle school or lower school chapel,
Okay.
when it's just them. Or
But again, I don't want to ask everybody.
yeah, I know, because only lower school and then lower school chapel.
But if you only ask lower school, then you've eliminated all the middle schoolers of having a chance to be asked, because they're not there. Eliana?
So for the 2, you go out during both of the recesses,
Okay.
and then you just pull some random people from recess to ask them.
Okay. So you would have to go to all recess times, right? And then, if you stand somewhere at the playground and ask each of the kids that goes by you, that would work, right?
That misses all the people in the other places, you just walking.
It does, yes. But I like that because then random kids are going to be out there and everybody's out there at some time. Donnie?
Just get 3, maybe 4 people from each class in low school, middle school, and high school.
Okay. Okay. Ask random groups of kids from each grade. That works. Evelyn?
Ask people. Okay, so ask a group of people who have been there for the longest time, and then ask a group of people who have been there for the shortest amount of time.
Okay. Bailey?
This might sound weird, but put everyone's name in a hat and then pull out 3.
Yeah.
Not
Yeah.
3, more than 3.
Not more than 3, but draw some. So being able to put everybody's name in a hat is actually a really good way of doing a random sample because everybody's name is in there. Everybody has a chance of being drawn out. So that's a pretty good one. What about one I was thinking about is before school drop off, where everybody gets dropped off. Because couldn't you ask one person from every car?
That's But then wouldn't that end up being everybody?
Oh,
Yeah.
I mean for a short period of time. I don't mean like all morning. Because there's pre-Kers that get out of those cars. You guys get out of those cars.
But then there are people who come late or don't come that
That's true. So, yes.
Then they couldn't.
Yes. But if you were doing a survey and you said everybody going through carpool in the morning will be asked or could be asked, like if they knew, then they'd at least have a chance of going. William?
I feel like what you could do is you could do like during lunch, they just go random, like you get like every staff teacher, every teacher goes and they pick one random kid
Okay.
from their grade or not from their grade, and then they bring it over and then they vote from those kids.
Okay.
So like
What
for
if-
example, you would take like, for
But those
example,
teachers
I like
wouldn't
that.
bias.
That would be good.
Miss Brock would take like.
That'd be good.
Jason
What if I went to both of the lunches and went down where everybody's seated and count 1, 2, 3, 4? I'm gonna ask you. 1, 2, 3, 4. I'm gonna ask you. Would that work?
Yeah, I mean,
As long as you go to both lunches, would it work?
Yeah.
Yes.
You chime.
Okay, because then really it just depends on where you sat that day whether you'd be asked, but you've got the chance of being asked. Okay. So a random sample is usually a representative sample. It's usually a good sample. So let's take a look at an example here of a survey they want to do. Morgan decides, remember Morgan? She's the girl that wants the stadium to be built.
oh,
Same girl. So Morgan decides to survey a sample of the town's voting population. How can she know that the survey results from the sample of voters represent the actual situation? So she wants a representative sample. So the first one, for the first sample option, she can survey a random sample or a randomly selected group of voters to make sure the results represent the entire population. So using a random sample is a good idea, right? She could be relatively sure of the options if it's a random sample. Option 2. Morgan could survey a convenient sample of the first voters she finds. Could she just go to a few people like the first one that come to her?
yeah.
Because often if they're like in a group and you probably have
Similar opinions. That's the trouble. So if you ask a group that came in a group, usually their answers are going to be the same because if they're together, a lot of times their opinions are the same then. Okay, so these results are not random and are not likely to represent the entire population. That would not be a random sampling. Because if you look in this list, she asked all the first, 15 people that she saw. That's not random. That's easy, but it's not random. And then her third option, Morgan could survey a randomly selected sample of voters. Because the size of the sample is very small, notice she has 3 people only here. Since her sample is so small, I'm troubling with my words. I'm troubling with my words, people. Her results are less likely to represent the population because it's way too small of a sample. Okay, so the size of the sample is going to matter whether it's representative or not. All right, questions? Kind of a lot to take in. Doesn't even feel like math class, does it?
No.
It's different than normal.
I feel like Mr. K's class.
Yeah. Okay. Produce manager. Do y'all know what a produce manager is? It is. Do you guys know what a produce manager is?
I'm gonna get
No?
something.
Do you know the produce section of a grocery store?
Yeah.
All the vegetables.
It's like the fruit and vegetable section, so it's the manager of that section of the grocery store. And they're trying to decide whether there's a customer demand to expand the organic food section or not. Okay, so they're trying to decide if it's worth their money. Wouldn't that be important to a company? Right? Because if they don't expand it and the customers want it, customers will go somewhere else. Or if they expand it and spend the money, but nobody wants it, then they're going to lose money. Like, it's important to see whether people want this or not. How could she obtain the information that she needs? How could she get a good random sample? Donnie.
They could, like, you know how you first walk
Yep.
into those sliding doors, just have someone like say, hey, like just ask you a question, or like set it up on a website.
Okay,
If
sure.
it's well known.
I like the idea of setting up like at the beginning of the store, because doesn't everyone walk through the front of the store?
Well, and
just
there
there
are
are
multiple entrances, and then
Wow,
you would get
yes,
a certain.
then you'd have other
Oh
people.
yeah, like a Walmart. And then you
Um,
have just a part of it. not all
That's
of
true,
it.
that's true. Would you wanna ask, like a family of 5 that walks through, would you wanna ask each of the 5 people?
No.
No, only one of them,
So that's-
because they're probably gonna think the same. So one of the group that comes in, and then one of the next group. Okay, so that's a good idea. How else could we? Claire?
Can I measure against that 5 people thing?
Okay.
Using my family as an example. I personally am the only one out of the kids who appreciate vegetables.
Oh.
Fruit.
Yes.
My siblings would rather not eat. So would that change up the?
It would, but if you are the person running the sample, you wouldn't know whether a family would agree or disagree. So your option would be just to choose one person. Yeah. And in something like this, would you sample the children?
No.
Probably not. Not for something like this. Probably one, whatever adult is with them is probably who you would ask. What else?
You could go, like, there are the different aisles, like, there are different food aisles. So there are a bunch of different groups of people who eat mainly different things. So you could ask, like, the groups of people in different aisles.
Yep. Okay, go to different aisles, that's good. Would you wanna go to everybody in the organic food section?
No.
No, that's not random. Okay, so you gotta make sure that you're asking everybody that's in the store. I mean, a little bit of everything. Bailey, did you have another idea?
Oh, while you're checking people out, you can ask a few people.
Oh, that's true. So if you're working at the cash register, you could ask every other group that comes through or something, yeah.
Well, if you have a lot of cat registers, you could, like, there's only a few of the population coming in, so you could ask all of them.
Yeah, yeah. Jude?
You could put like a box somewhere and then like have a question
Yep,
and then like for them to put their vote in the little box.
sure. You could actually run it as a vote. Yeah?
The little, this gives everyone a chance if they do it, but it gives everyone a chance, but only a few people will actually do it. Like at the self-checkout, you know how you have to go through all the screening process, like swipe your card and all that. Like there, it can just pop up yes or no, like a yes or no question, put in your vote or something
Okay.
on the screen, tap.
If you did that, would it be okay to just use the self-checkouts? Or would you need to ask at the other registers as
Yeah,
well?
like the little card
Well,
machine.
Yeah,
That you have to sign your.
yeah, that's what he's, yeah, so,
And like at the beginning, I always show like a message like thank you for choosing.
Yep. or whatever, wherever it is that you're at. Okay, next. In a moment it will be, here we go.
Can I ask to the last one?
What?
Like,
Sure.
you can ask like on like the middle age group because like they probably know like a little bit, or like the older group because
Maybe.
maybe.
Maybe. Okay, so Morgan has decided on a sample. She decides to survey a sample of the town's voting population. How can Morgan generate a random sample of the town's voting population? So we went through a couple of samples options for Morgan earlier, and all of them, one was too small, she only asked 3 people. One was, she asked the first people she gave to like a group of people, and we said that wasn't good. So what would be a random sample of a town's population? How could you do a random sample? So instead of ideas, I'm actually gonna go through what their suggestion was here. So first, you have to define the population. And in this case, the population consists of all the registered voters in the town. So everybody that gets to vote, that's what the population is. So that would include everyone 18 and older. This would not apply to 17 and younger because they don't get to vote anyways. right? So they're not, so it's not actually the entire population, it's just the registered voters. So we know who we're looking at. Step 2, you have to know the sample size. So how many people is enough people to ask? If we were asking our school, would we want to ask 100 people?
No.
That's because, I mean, that's a lot of the people. So maybe 30 would be acceptable. But, so the sample size depends on the population size. It says to make or acquire a list of all the members of the population. Oh, this is interesting. We haven't done this yet. So she's going to find a list of all the registered voters, which she could get from one of the government agencies. They'd be able to give a list. She's going to assign a number to every member in the population. And what do you think she could do with that? If you give every person a number, yes.
Go onto Google and search random number, like picker, like. put in
It's called a random number generator.
Yeah, random numbers.
Yeah, so your calculators and computer applications and phone applications, apps, can do random number generators for you. So you hit a button and it just shows you a number. You hit the button again and it shows you a different number. So whatever number it shows, you could ask that person, whatever name is assigned to that person. Yeah.
You can do that on your calculator?
We're not doing that right now though. Eventually we'll do probability and I'll show you how to do that. Okay, so this one just says generate a list of random numbers. You can have technology create the random list of numbers for you. And that's completely random then, right? You didn't even choose who to ask. Your technology kind of told you who to ask. I do want to make sure you're aware of this. The larger the sample, the more confident you can be. So asking 100 people is a lot more accurate than asking 50 people. The larger the sample, the more accurate you are. A different scenario. We're not talking about Morgan anymore. Ravi is running against 2 other candidates for student council president. All of the 750 students in Ravi's school will get to vote for student council president. How can Ravi generate a representative sample that will help him determine whether he might win the election? So first, I want you to write down a few things or come up with some ideas. So in Ravi's example, oops, this is example 1. What is the population? That's the first thing. In the example that we just read, what is the population? Like, who does he need information from? Ivan?
750 students.
Okay, so it was all 750 students. Why is he including the entire school?
Make it fair.
Yes.
Everybody.
Eliana?
Everyone can vote.
Everybody gets to vote, so we've got to include everybody in our sampling then, because everybody's idea is going to matter at this. For his sample, what do y'all think would be an acceptable sample size? 50?
I
Huh?
would say 80.
100? 80?
95.
Would 10 be fine?
No.
10?
That's
75th.
10 out of 750 is not a very large sample.
Like that would be
Okay,
good with
so
the-
I would say a sample would be between maybe 50 and 100 students.
I think that's too small for some.
It might be. It might need to be larger than that even. But no lower than 50, for sure. No lower than that. 750 is a lot of kids, so you need to have a larger sample space. What else were we supposed to do here?
The next is make or acquire a list of all the population.
Oh, that was one example. So how could he find his 50 to 100 people to ask? We've come up with a lot of ideas already. I want to see if you have any new ones. How could Ravi determine a good random sample of about 50 to 100 students total? Carolyn.
So, let's say he goes to public school. There's like lunch A, lunch B, lunch C,
Okay.
all those
Yep.
different lunches. So, he could go and like ask at least 2 people in the grade, or 3, 5, somewhere around there.
Okay.
In each grade at lunch A, because it might be a certain grade. Then he can do that the same for lunch B and C.
Okay. So he could choose. He could choose, let's say, 10 to 15 students from each lunch. I mean, it depends on how many lunches they have. Here, we'd have to ask more than that. How could he make sure the 10 to 15 was random? Like, at each lunch, how could he choose his 10 to 15 people? William?
So he could because tables,
Mm-hmm.
they're probably, if they're like a school, with like, they'll probably have tables.
Yep.
And what he could do is he could go and ask one person from each table.
Okay,
Or
so
from each lunch.
maybe one person from each table.
And if he still doesn't have enough, he could then he could go and ask one of the bigger tables.
Sure.
Like
Yeah.
the bigger tables instead of like maybe a small table with only 4 people.
Yeah.
You go ask a table with like 10 people.
Okay, have a seat. I like that idea because if you're seated at a table with other people, usually it's a friend group. So you wouldn't want to ask the entire table because it's typically then not going to be random because they're going to think kind of the same things. So I think that's a pretty good idea. And I think we have one more. Thanks, yeah. That's more than normal. I thought this was another vocab. I'm not sure though. Oh. Video.
Morgan and Maddie will each generate a random sample of the 138 students in 7th grade at their school. They each write the numbers from 1 to 138 on small pieces of paper and put them in different hats.
This was Bailey's idea, I think.
Next, they
Wasn't it?
draw numbers randomly from their hats. Here are the numbers that Morgan drew. And here are the numbers that Maddie drew.
A robot?
What do you notice about the 2 random samples taken from the same population? What does this tell you about the sampling technique?
Okay, what do you notice? Morgan drew 20 numbers from the hat, 1 through 138, and Maddie drew 20 numbers from a hat, 1 to 138. What do you notice about the list? What do you notice about the numbers, Landon?
Most of them are different, but I think they're the same.
Yeah, but most of them are different, right? And they're not in order. It's not 1, 2, 3, 4, 5. That is a very good random sample. So drawing numbers out of a hat is the same thing as using a number generator on a technology. It's going to turn out to be about the same randomness level. They're good samples. Claire? Is your hand raised for something? Some of them are the same. Yes. Any of them that are the same, you would only ask them once. Yep. Not twice. You don't ask them twice.
They don't count.
Here are some observations of the samples. There are 20 members in each sample. The only common numbers to both samples are 38 and 106. And the numbers are distributed differently in each sample. The distribution of data can be shown by a histogram.
That's
A
how many numbers
histogram is a
were
graphical display of data
drawn.
that is grouped into ranges. What does the histogram show about Morgan's sample?
The heights of these should be all over the place if it's a random sample. So the kids that had numbers less than 20, they had 2 in that section, 3, 4, 1. That's a very random sample. There's a little bit of every number.
The histogram shows an uneven distribution. Morgan shows more numbers between 81 and 100 than in any other range. He chose only one number in the range of 61 to 80 and in the range of 121 to 140. How do the histograms help you compare the two samples?
We can tell are different. Okay, they're definitely different. William?
It shows you that Maddie's sample is a little bit more even,
Mm-hmm.
and that Maddie, if you had to choose one of them, if they had both their samples and you had to choose which one you think would be representative, and more, I think it'd be more Maddie because it's more spread out.
Yeah.
Like everyone, I think at least has 3. If I'm correct.
Two. Everybody has at least two.
Oh
Okay.
yeah, at least 2.
Let's see what they say.
The histograms show that the data is distributed unevenly, but differently in each sample. Every range is represented with at least one value, and at most 6 values in a sample. We can conclude that the sampling method produces random samples that have mostly different members, but that are each likely to be representative of the population.
Okay, so I want you just to write one other thing down on here, on your notes. Let's do some examples of good random samples. Good random samples are drawing from a hat. That is usually a representative sample. A random number generator is usually a representative sample. It's a good random sample. Let's do, those are the only ones they've mentioned as good, so I'm gonna leave those as the good ones. And then bad random samples, and I don't actually mean bad. I just mean less good, okay?
Not that good.
Not that good, okay? The less than good random samples, what were some that they did? Ask
A whole group.
a whole group, one whole group, that's bad. Okay, that's not a representative sample typically. Ask the first people you see. That's not usually a representative sample. Eliana? Oh, yeah. Ask a small sample, that's not good. They did specify that one, so asking 3 people out of 500 is not good. William, give another one?
Asking only like, if it was students, only 1 grade. So it's kind of like almost asking 1 whole group.
Okay.
Like asking only 1 grade.
Limiting your sample. How about that? Like to 1 grade or to 1 group or to 1 whatever. Landon? Carolyn?
Asking too large of a group.
Oh, that's true too. I'm not gonna write it down, but I do wanna talk about it though. Carolyn said asking too large of a group. Why is that a bad random sample? Mateo?
If people are not gonna have the same opinion.
Maybe. That actually makes it a better sample. But why is it just a bad idea? Evelyn?
No, it's not like a random sample. Like it's not 2 out of 5. It's like 4 out of 5. So
Yeah.
It's not.
Isn't it just like asking everyone?
It's kind
Then it's not a sample anymore then. It's now you're just asking the population. It's not a sample any longer. Eliana?
You can overrepresent something. Like you ask a bunch of people who say yes, and only a few of them end up saying no, but a bunch of the people that you haven't asked.
Yeah.
A few people.
Then
that
it's
you
not
haven't
random. Yep. Okay. So you don't really have time to get started on your homework, but it is online. 6.1 online.